All right, let's talk about gravity. I mean, it's this force we feel literally every second of our lives, right? But here's the thing. It is packed with some of the biggest contradictions in the universe. Seriously, it's a paradox that keeps even the smartest physicists up at night. So, that brings us to the big question, the one we're going to unravel today. How can a single force be both the absolute weakest and, at the same time, the most powerful force in the entire cosmos? I know, it sounds completely impossible, but trust me, stick around because the answer to this is going to change the way you think about, well, everything. Okay, check this out. You've probably done this a million times without thinking about it. You take a tiny little fridge magnet and you pick up a paper clip. Now, stop and think about what's actually happening there. That dinky magnet is winning a tug of war against the entire planet Earth. We're talking about a 6 sextillion-ton giant, and it's losing to a magnet you got for free on a pizza box. This isn't some crazy science experiment. It's right there in your kitchen, and it's the perfect example of this paradox. All right, so let's dig into the first half of this mystery. Just how ridiculously weak gravity actually is, especially on the small scale. And look, this isn't just a feeling physicists have. It's a huge, measurable puzzle in physics. So big it even has its own name, the hierarchy problem. So for a little bit of context, you've got to know that everything in the universe is run by four fundamental forces. You have the strong and weak nuclear forces. They're the heavy lifters inside an atom, holding it all together. Then you've got electromagnetism, which is, light magnets, all that good stuff. And then there's gravity. It's kind of the black sheep of the family. And when I say it's the black sheep, I mean it is just shockingly, absurdly weak. Let me put a number on this for you. Electromagnetism is about 10 to the 36th power stronger than gravity. Okay, what does that even mean? That's a 1 followed by 36 zeros. It's a number so big it's almost meaningless. Our brains literally can't picture a difference that huge. And that massive, mind-boggling gap is exactly what physicists call the hierarchy problem. This isn't just some fun trivia fact, you guys. It's one of the single biggest unsolved mysteries in all of science. Why? Why is gravity such a pushover compared to everything else? We just don't have a final solid answer. It's a huge question mark. Okay, so we've got it. Gravity is the runt of the litter. It's pathetically weak. So how in the world does this feeble little force become the master architect of the entire universe? I mean, how does it build planets, stars, galaxies, the whole shebang? Well, here's gravity's secret weapon. See, the other forces, they have rules, they have limits. The nuclear forces only work on crazy small scales, inside atoms. Electromagnetism needs a charge to work, and positive can cancel out negative. But gravity, it has two killer features. One, its range is infinite. And two, it affects everything that has mass or energy. And here's the most important part, it never cancels itself out. It only ever adds up. And that cumulative effect, that always adding part, that's the whole ballgame. Think of it like a cosmic snowball rolling downhill. A tiny bit of mass starts to pull in another bit of mass. Now they're a little bigger, so their gravity is a little stronger. So they pull in even more mass. And this just keeps going and going for billions of years until you've built planets and stars and entire galaxies. Gravity's weakness is overcome by its incredible, unending persistence. But that's not even the whole story. To really, truly get why gravity is the boss, we have to kind of throw out everything we think we know. We need to step into the truly bizarre, warped reality that Albert Einstein showed us. Yeah, this was a total game changer. For hundreds of years, everyone, including Newton, thought of gravity as this simple pull, right? Like an invisible rope connecting two objects. But then, in the 20th century, this guy comes along and just flips the table on the whole idea. He proposed something so radical, it basically redefined reality. See, Einstein said gravity isn't a force in the universe at all. Gravity is the shape of the universe. It's not a pull, it's a curve. It's the literal geometry of reality. Okay, what on earth does that mean? Well, his idea is that anything with mass or energy, like the sun or a planet, literally bends and warps the fabric of spacetime. The classic analogy is a bowling ball on a trampoline. It sinks down, creating a big curve. Now, if you roll a little marble nearby, what happens? It curves towards the bowling ball, but the ball isn't pulling it. The marble is just following the straightest possible path on a now curved surface. That's what the Earth is doing around the sun. It thinks it's going in a straight line, but space itself is curved. And that is the real secret to gravity's power. That's the solution to the paradox. Gravity isn't strong because it's a good puller. It's strong because it literally writes the rules for the universe. It shapes the stage where all the other forces have to perform. It's not just another actor in the play, it's the director, the set designer, the whole thing. But, and this is the really cool part, even with Einstein's genius, the story is far from over. In fact, his revolutionary ideas just opened up a whole new can of worms, a bunch of new, even stranger questions that scientists are still battling with right now. The mystery just keeps getting deeper. So what about that hierarchy problem, that weird weakness? Well, some of the proposed answers are straight out of science fiction. One of the biggest ideas comes from string theory, and it suggests that maybe gravity isn't actually weak at all. Maybe it just seems weak to us because most of its strength is leaking away into other dimensions, extra hidden dimensions of reality that we can't see or touch. I mean, how wild is that? And the big questions don't stop there. We still have no idea how to make gravity play nice with the super weird rules of quantum mechanics. They just don't fit together. And then there's dark matter. We see its gravitational effects everywhere, holding galaxies together, but we have no clue what it is. And we've literally just started to detect gravitational waves, actual ripples in the fabric of spacetime. It's a whole new way of seeing the universe. So we're back where we started. It's this beautiful paradox, isn't it? Gravity is so weak that a tiny magnet on your fridge can beat it, no problem. And yet, on the cosmic scale, it's the most dominant, unstoppable force there is. It's like it lives in two different realities at once. When you really think about it, you can't block gravity, you can't turn it off, and you can't escape it. It's what shapes everything we see, from our own little planet all the way up to the biggest clusters of galaxies. It is the quiet, patient, and powerful architect of our universe.